so let's continue right where we left off. Okay, so let's look at one more example. So if g of x, okay, so maybe pause the video, try it, and see if you get it right. Okay, so first thing I'm going to do is I'm going to rewrite. Now I'm going to take that derivative. So negative 2 times 3 is negative 6. I have to subtract 1, so negative 2 minus 1 is negative 3. Now the negative 3 only applies to the x, not the 6. And the 6 is just a negative number, so it's not going anywhere. And there it is. Okay, so very convenient compared to how we started out. So we can see that it's pretty brutal going through that. Okay, let's look at the fifth one, and we call this the sum and difference rules. Okay, and basically it just says that if terms are added and we should say subtracted, just add or subtract the derivatives. And we'll do an example, and that'll make it really easy to see what I'm saying. Okay, so just think of these as all little pieces, and we can just do all the little pieces together. Okay, so all I'm doing is I'm just pretending, okay, if it only said that, the derivative of that would be 3x squared. Okay, now I'm going to do the derivative of this. I'm going to go 2 times negative 5 is negative 10. 2 minus 1 is 1. Okay, the derivative of the x is just 2, because this is like a little 1 right here. And 1, okay, so if I go 1 times 2 is 2, and 1 minus 1 is 0, x to the 0 power is 1. So I just get a 2 there. And then remember we said the derivative of a constant is 0. So that is our solution. Okay. Let's say we had something really fun. Like that. Okay, so here we go. So I'm going to bring down the 5. And then 5 minus 1 is 4. Bring down the 4. 4 minus 1 is 3. 2 times 3 is 6. 2 minus 1 is 1. the derivative of a constant is 0. So those are going to reduce to 1. And there is our derivative. So, like I said, you'll get to the point where you can easily do these guys in your head. Okay. Just a couple of more. Just a couple more. So I'm going to do one more example that goes with number 5. And I want you to see like a nice little quick way of doing this. So let's see, that was A, B. Let's do C. And let's say that we had 8x cubed plus 4x squared minus 3 all over x. And you probably want to make a note about this one, because this seems like fine when we're doing this, but later on when we learn the quotient rule, a lot of people want to use the quotient rule on it, and that's a really hard rule to use if we don't have to. Okay, so if there's a monomial down here, okay, in the denominator, you're going to always simplify first. Because the power rule is the easiest rule to use. So we don't want to use any other rules if we can use the power rule. So think about this, that this is really 8x cubed over x plus 4x squared over x minus 3 over x. Okay, now I'm just subtracting. This is like a little 1 right there. 3 minus 1 is 2. This I'm going to bring to the top. Okay, so I haven't done anything. Oops, I probably should have had like an f of x here. Okay, so I haven't done anything to it yet. So this is still f of x. I'm just simplifying. But now that it's in this form, well, actually, you guys try it. Pause the video, try this one, and see if you get it right. Okay, 16x plus 4 plus 3 x to the negative 2. Okay. So this f prime of x is 16x plus 4 plus 3 over x squared. And so you can really see the advantage. If we had to do this thing using our big long definition of the derivative, it would take forever for us to do. Okay, the very last one that we're going to look at, number 6. These are the derivatives of the sine, the cosine, and the tangent. Now, we can go through a big old proof, and we can use the definition of the derivative to show how to get these right here. But I don't want to do that right now. So we're just going to memorize these for right now. And note, and I might have you do it at some point, that we could prove it using our definition of the derivative of what they are. Okay, here's what I want you to know. The derivative of the sine of x or the sine of theta, it doesn't matter what we put in there. Well, the derivative of the sine is the cosine. The derivative of the cosine is the negative sine. And again, it all has to do with just slopes of the line. And the derivative of the tangent and when we fill in the rest of these, I'm going to show you guys a nice little thing that I use that helps me memorize them, because eventually we'll also do the derivative of the secant, the cosecant, and the cotangent. But for now, memorize these three. And with these, I would start like a little, little cards, little index cards that you keep these on, and because we're going to have a lot of derivatives. Let me see if I can find a thing that will show you, like, over the next several months, derivatives that we need to memorize. And let me see if they're, not too bad. This little sheet, it has these ones here. We're going to memorize these in the first couple of days. And let me see if it has. Ooh, we have to memorize more than that. And then we'll have a thing called integrals, and we'll be memorizing all of these as far as we go backwards. So this is kind of a thing that, for right now, you want to start like getting these together, little cards, little index cards. You can get these little index cards on Amazon that are like half size, and they're really cute, and they work really good for doing this. Okay, so let's look at a couple of examples. Okay, so let's just say we have f of x and I want the derivative of that. Okay, so right now we don't know the product rule, so I just want you to note for right now that you're just going to leave the constant on there. And like I said, it's not magic. We'll go through the proof at some point. I'll show you the product. I'll show you it from different perspectives of why that -4 is going to stay there. But I just want you to go, okay, for now, I'm just going to leave that alone. And I know that the derivative of cosine of x is negative sine of x. So the derivative of -4 cosine x is 4 sine x. Okay, so just leave that little constant alone for right now. Okay, that's it. So what I would like you guys to do before tomorrow is I want you to try these problems. Let me shrink them down. Okay, so try these in your notes, and then we'll check them tomorrow. Maybe just take a screenshot of that and see how you did.